This is the solution video for section 1.5, problem number 9. So here it says find the limit if it exists. So the limit as x approaches negative infinity of 4x minus 3 over the square root of x squared plus 1. So our first step in any limit problem is to substitute. So I have 4 times negative infinity minus 3 divided by the square root of negative infinity squared plus 1. All right, so 4 times negative infinity, that's negative 4 infinity, or negative infinity minus 3, but that's still negative infinity, divided by negative infinity squared, so that'd be positive infinity plus 1, so that's infinity, and the square root of infinity is infinity, so I get negative infinity over infinity. Now, it's very important to notice the fact that this is a negative, all right, and we'll come back to that in a moment, but this answer has to be negative. As you plug in more and more negative numbers, like negative a million, negative 10 million, negative billion, whatever, this result is always going to be a negative number. All right, so now, how do we deal with infinity over infinity? Well, we're going to divide by the highest power of x. Well, that is actually kind of weird here because it looks like the highest power is squared, which it kind of is, but remember, this is actually the square root of x squared. So it's really kind of a single degree, but what we want to do is we want to take the square root out because it's kind of confusing. It's like a function within a function. But the problem is that there's no square root in the numerator. So can I bring a square root into the numerator? So I have the square root of 4x minus 3. Well, I can't just arbitrarily square root, but what if I square root and square 4x minus 3? Then is this result the same as what I had initially? And the answer is yes. So that's what I'm going to do. Now, if you remember some rules of powers here, these square roots are both on the numerator and denominator. So I could actually rewrite this as the square root of the entire fraction, 4x minus 3 squared divided by x squared plus 1. So that means then I can use the property of limits that we discussed before to bring the square root out. So now I have the square root of the limit as x approaches infinity, negative infinity, of 4x minus 3 quantity squared divided by x squared plus 1. So now, forget about the square root. Now we want to evaluate this limit. So now it actually is that x squared is the highest power, but what we want to do is we want to take that numerator and multiply it out. So the limit as x approaches negative infinity of 16x squared minus, we would get a 12x, so 4x times 3, and another 12x, that'd be minus 24x, and then plus 9. All of that divided by the x squared plus 1. And remember, don't forget about the square root. All right, so now we want to divide everything by x squared. So I have the square root of the limit as x approaches negative infinity of 16x squared over x squared minus 24x over x squared plus 9 over x squared, all divided by x squared over x squared plus 1 equals, still have that square root, and then we're going to simplify, x approaches negative infinity. All right, so now 16 minus 24 over x plus 9 over x squared divided by 1 plus, I forgot to divide by x squared there. So 1 plus 1 over x squared. All right, so now we're going to reevaluate. So now I have the square root of, so I get 16 minus 24 over negative infinity, that's 0, plus 9 over negative infinity squared, that's 0. So 16 minus 0 plus 0, that's 16. And then I have 1 plus 1 over negative infinity squared, that is also 0. So I have 16 over 1. So I have the square root of 16, which is 4. Now, it looks like that is positive 4, but let's go back. We said that this result was always negative. So let me remind you, anytime in algebra that you bring in a square root that didn't exist before, you need to include a plus or minus, which means that we have a plus or minus outside this, a plus or minus outside this, a plus or minus out here, 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 and a plus or minus here. So which one is it, the plus or the minus? Well, we discussed initially that this result was always going to be negative. So we actually only want the negative, and our answer is then -4. So this is actually an example of a problem of a function that has a graph where there are two different asymptotes. So if you are going towards negative infinity, then that means you are approaching -4. But if you were approaching positive infinity, you meaning going to the right, you're actually approaching +4. And I'm not really sure, or just off the top of my head, what's going on here, but that's not relevant because we're only talking about the end behavior.